Ready? We're back again. We're going to do quiz 5-7, number 1. People have trouble getting the constants. Notice we're now doing integration. We are given the derivative and we're working backward to the function. So the first thing is we're given the derivative of c with respect to x is 3x plus 20. The derivative with the revenue with respect to x is 44 minus 5x. And whenever x equals 80, the cost is 11,400. We'll see how we use that. Find Rx. Well, we take MR is equal to 44 minus 5x, multiply it by the dx, distribute. The integral equals the integral of 44 dx minus 5x dx. Rx is now equal to 44x. Dx becomes x minus 5. Do our simple basic power integral. 1 plus 1 divided by 1 plus 1 plus c. 44x minus 5 half x squared plus c. Now we have to find c. We usually assume for a revenue when x equals 0, Rx equals 0. So we go into here and we put 0 for all our x's. 44 times 0 minus 5 half 0 squared plus c. So c equals 0. So our revenue function simply becomes 44x minus 5 half x squared. Okay, now we have to find our cost function. As usual, I'll erase half the board just in case you haven't gotten the rest of it. This blue I see it's hard to erase. Okay, so B is find the cost function. So dc dx was our marginal cost, and that was equal to, go back, I have to go back to the first page now. Just give me a minute. It's on the second page. Let's see, dc dx is 3x plus 20. So dc, the integral is going to be the integral of 3x dx plus the integral of 2 dx.
The 20? I think it's 20.
It's 20. Okay, so c of x becomes 3x1 plus 1 plus 20x plus c. Well, c of x becomes 3 halves x squared plus 20x plus c. Now we want to find c for the cost. All right, so what is c? Well, we're given when x equals 80, this is 11,400. So what I'm going to do is I'm going to substitute that 80 into the equation. So when x is 80, this is 11,400. And that's going to be 3 halves times 80 squared plus 20 times 80 plus c. So now we have 11,400 equals, and I've already calculated this, is 9,600 plus 1,600 plus c, or 11,200 plus c. Bring this over here, c is 200. Substituting back into my cost function, I have the constant it's 3/2 x squared plus 20x plus 200. And this pen is gone. I'm getting new pens for our review class. So what do they ask you to find now? They ask you to find the profit function. Okay, so let's find the profit function. And the profit function is the revenue function minus the cost function. And the revenue function, I left on the other side. I believe that came out to be 44x minus 5/2 x squared minus bar 3/2 x squared plus 20x plus 200. Distributing the minus sign, we have 44x minus 5/2 x squared minus 3/2 x squared plus 20x plus 200. Adding 44, I think one is a negative, isn't it? This is going to be a negative, and this is also going to be a negative because I forgot to distribute. Minus times a plus, minus times a plus, minus times a plus. Okay, so this is 20x, make it a little bit clearer. 44 minus 20x can be 24x. Minus 5/2 minus 3/2 x is minus 8/2. It's minus 4x squared minus 200. And that represents my profit function. Okay, 24x, right. Okay, now they wanted you to find the value of x that maximizes profit. Once again, I'll leave it a little bit on the board. So, find x that maximizes profit. First, you find the critical points. Set your derivative equal to 0. The derivative of your profit function is 24 minus 8x. I believe minus, yes, 24 minus 8x. And we're going to set that equal to 0. You get 24 equals 8x, or x equals 3. Now that's your critical point. I don't know if that's maximum or min. Here I'm going to take the second derivative, which is going to be minus 8, which is always less than 0. So x equals 3 is at a maximum. Maximum profit point. All right, let's extend this problem a little bit to talk about inflection points. This was not part of the problem on the test, but let's say it asks you part D to find all inflection points. Well, you see, I really can't do it because I have P double prime P is minus 8. So this because of that, because of P double prime X is minus 8, there are no inflection points here. So let's take another problem and see if we can use this problem to find inflection points. This was actually taken on your, here it is. This is taken on your in-class test number 1. Okay, what you were given, this is test number 1 in class, where you were given px is x third over 3. Actually, I minus x third over 3 plus 2x squared plus 2x. Yeah. Now you want to find inflection points, so you take the first derivative. Okay, the first derivative is going to be, I believe this is 3x third. Yes, okay. Minus x third plus 2x squared plus 2x. Okay, it's going to be minus 3x squared. That is the one I want. Plus 2. And I'm going to take the second derivative. It's going to be minus 6x plus 4. Set that equal to 0. I'm not sure where we okay, minus 6x plus 4 is equal to 0, and my 4 equals 6x, x equals 4 over 6, or 2/3. Now, is that an inflection point? We have to use our second derivative test. Our second derivative sign test. So we put 2/3 here. Okay. I could take 0 in this case. Okay, that would be less than 2/3, and I could take 1 here. So P double prime 0 is going to be, and P double prime x, of course, was minus 6x plus 4. Minus 6 times 0 plus 4, so that's 4. That's greater than 0. P double prime 1 minus 6 plus 4 minus 2 is less than 0. This is at a max, so I get this concave down. I'm sorry, this is at a minimum. Sorry, greater than 0 is a minimum. This is going to be a smile, concave up. This is at a max. That's going to be concave down. So yes, it is. So x equal 2/3 is an inflection point because we get a change in concavity around that point. Is it a point of diminishing returns? Yes. You go from a smile to a frown. You're sad because your returns are diminishing. And yes, x equals 2/3 is a point of diminishing. And you can be sure that there's going to be a problem like that on the final. Okay, how much time do we have?
We're coming right up on 15 minutes right now.
We'll do.
Do one more?
Yeah, I want to do one on integration. Yeah.
All right.